Hello, welcome student, and we are start to discussions of the new topic, that is topic number 14, the last topic of the 11th standard physics, and the topic name is the semiconductor. We are just discussed the two lectures in these topics, and today we are start to discussions of the new content of the related to the topics, that is semiconductor, and the content will be band theory, that is band theory. In the first lectures I will be drawn one of the diagram here for the explanation of what is exactly happened inside the semiconductor materials. I will be drawn two different types of the bands, that is valence band as well as conduction band. Valence band, the valency, presence of the electrons in the valency, this is called as valence levels, and the energy band of that corresponding energy band is called as valence band. In this sodium metals, we have in the sodium, that is the sodium, and atomic number of the sodium is 11. The number of electrons of that sodium will be 11s. Then we writing the electronic configurations of that, the some field, that is I will be said to cell, the S cell, P cell, D F, they are some completely filled, and end of that the S will be end ला जे काय असते S, the spin electron, S cell, spin cell will be half filled. S च्या त्याची व्हॅलेन्सी जी काय आहे ते व्हॅलेन्सी 2 असते, बट त्यामध्ये काय आहे एकच इलेक्ट्रॉन्स अवेलेबल असल्यामुळे हाफ फील्ड असते, आणि ह्या बँडला म्हटलं दिस एनर्जी इज कॉल्ड ॲज व्हॅलेन्स एनर्जी. द टॉपमोस्ट ऑक्युपाइड एनर्जी लेवल, द टॉपमोस्ट ऑक्युपाइड एनर्जी लेवल्स, त्याच्या अगोदर डी असणार आहे, त्याच्या अगोदर पी असणार आहे. त्या पी मध्ये कम्प्लिटली इलेक्ट्रॉन्स कम्प्लिटली फिल्ड झाल्यामुळे ते काय असणार आहे कम्प्लिटली ऑक्युपाइड असणार आहे. देन दिस इज द हेडिंग व्हॅलेन्स बँड. Valence band. In the valence band, the topmost occupied energy level, the topmost occupied energy levels, the topmost occupied energy level is called, this is not a energy levels, that is topmost occupied level is called valence levels, is called valence level, and the corresponding band energy, the corresponding band energy band, the corresponding energy band is called valence band. Valence band. In the first lectures I will be drawn one of the diagram here, and I will be again the drawn same diagram for the explanations of band theories. Let's see. This is the valence band. Be drawn here the valence band, and the next band is conduction band. Next type of the band is conduction band. This is called conduction band. The immediate next level of electron after the valence band, immediate next level of the electrons after the valence band, this is called as conduction levels. The immediate next level of electron after the valence band, after the valence band is called conduction level is called conduction level. This is for MCQ. What is the difference between conduction band and valence band? The conduction band, I will be said in the first lecture, the valence band may be completely filled or partially filled, but conduction band is complete, could not be completely filled. They partially empty or completely empty. The immediate next level of electron, next level, immediately next level of the electron is, this level is called as the conduction level, and the corresponding energy band, the corresponding energy band, the corresponding energy band is conduction band. I will be write CV for the short form of conduction band. This is all about the conduction band. I will be let's write or draw the conduction band here, that is the CB, conduction band. The gap between, this is the conduction band and this is the valence band. This is up next energy levels of that particular electrons, and the gap between, what is the gap? Then I will be write the next definition. The gap between bottom of conduction band चे जे खालचं गॅप आहे, the gap between bottom of conduction band, that is CB, and top of valence band, जे valence band च्या वरच्या भागातली गॅप आहे, top of valence band is called band gap, or energy gaps, or energy gap. Then the gap between bottom of the conduction band and top of the valence band, this gap is called as band gap. That is band gap. I will be right here BG, and the energy of the band gap energy is EZ. Why will I use the EZ there? Why will I explain the energy between the band gaps? Let's see in the next points. What we discuss here, the valence band, the topmost occupied level is called as valence levels. The corresponding band energy, the energy band is called as valence band. The conduction band, the immediate next energy levels or immediate next level of the electron after the valence band is called as conduction levels. It's called as conduction level, and the corresponding energy band is called as conduction band. This is the, we are seeing the difference between the conduction band and valence band, and the gap between the bottom of conduction band, the gap between the bottom of conduction band and top of the valence band, this gap is called as band gap. And this structure is shows only, this is structure is only related to the energy of electron. This structure is only related to the energy of that electrons, not related to the physical structure of that solid. This is not related to the physical structure of solids. This is only related to the energy of that particular electrons. Then we are using some derivations here for the proper explanations of what is exactly happen here. Then at a particular temperature, T, at some finite value of the temperature, that is T, a few electrons get thermally excited. Few electrons, I will write here E minus, electrons gets thermally excited, from the valence band, thermally excited in the order of kT. The T is a finite value of the temperature and K is a Boltzmann constant. In the order of, that is thermal energy, that is I will be right, the thermal energy is proportional to the temperature T and K is a constant here. Okay. Then at some finite temperature, finite value of the temperature T, the few electrons get thermally excited. The few electrons gets thermally excited in the order of kT, and this K is called as Boltzmann constant. Then only electrons from the valence band can be excited. I will be right here. Only electrons from valence band can be excited, not from the conduction band. Only electrons from the valence band can be excited thermally, to the valence band, excited to the conduction band thermally. Then only electrons from the valence band can be excited. म्हणजे फक्त इलेक्ट्रॉन्स जे काय आहेत किंवा जी काही मी या ठिकाणी अशा पद्धतीने जी काही डायग्राम ड्रॉन केली होती, दिस इज द व्हॅलन्स बँड हिअर अँड दिस इज द कंडक्शन बँड. देन यामधून जे इलेक्ट्रॉन्स आहेत यामधून डायरेक्ट एक्साइटेड होत असतात इन द कंडक्शन बँडच्या डायरेक्शनमध्ये. इन द फर्स्ट लेक्चर्स वी आर डिस्कस हिअर इन डिटेली. I could not be explained here. That is, from the to the conduction, the electrons from the valence band can be excited only to the conduction band thermally, and this thermal energy gap and the thermal energy, of that electron must be greater than band gap energy. That is band gap energy in the bracket, that is easy here. Then जी काही इलेक्ट्रॉन्स थर्मल एनर्जीने एक्साइटेड होणार, जे काही केटी असणार आहे, द केटी इज मस्ट बी ग्रेटर दॅन इझी. वाय? बिकॉज ही जी एनर्जी आहे, द एनर्जी ऑफ बँड गॅप एनर्जी इन बिटवीन द कंडक्शन बँड अँड व्हॅलन्स बँड, यामधून जर ह्याच्यापेक्षा जर जास्त त्या इलेक्ट्रॉनची थर्मल एनर्जी असेल तरच ते डायरेक्टली जात असते त्यामध्ये, म्हणजे कंडक्शन बँडमध्ये डायरेक्टली ट्रॅव्हल करू शकते किंवा एक्साइटेड होऊन कंडक्शन बँडमध्ये जाऊ शकते. बट जर थर्मल एनर्जी, टेम्परेचरची जी एनर्जी आहे ती एनर्जी या बँड गॅप एनर्जीपेक्षा जर कमी असेल, द एनर्जी, थर्मल एनर्जी विच कॅन बी एक्साइटेड टू द इलेक्ट्रॉन्स इज लेस दॅन the band gap energy, then the electrons could not be enter in the conduction band or could not be excited to reach the conduction band. Then अजून एक जी पद्धत, हे झाली टेम्परेचर इंक्रीज करून इलेक्ट्रॉन्सला एक्साइटेड केलं जातं. बट वन अनदर मेथड वी आर यूज टू एक्साइटेड दॅट इलेक्ट्रॉन्स, वी यूज द इलेक्ट्रिक फील्ड, external electric field are also excited to that electrons which are in valence band. आपण एक्सटर्नल इलेक्ट्रिक फील्ड अप्लाय करून देखील त्या इलेक्ट्रॉन्सला एक्साइटेड करू शकतो. बट ही जी काही एनर्जी आहे, एक्साइटेड झाल्यानंतर जी काही इलेक्ट्रॉन्सची एनर्जी असते, द इलेक्ट्रॉन्स एनर्जी दे आर एक्साइटेड आफ्टर द अप्लाइंग इलेक्ट्रिक फील्ड दे आर लेस दॅन व्हेरी व्हेरी स्मॉल अमाऊंटमध्ये असते, त्यामुळे हिची काय एनर्जी बँड आहे ही एनर्जी बँड जास्त असल्यामुळे ते एक्साइटेड होऊन कंडक्शन बँडमध्ये जात नाही, त्यामुळे एक्सटर्नल इलेक्ट्रिक फील्ड अप्लाय करून आपण कंडक्शन घडवून आणू शकत नाही. दिस इज ओनली वन मेथड टू इन्क्रीज द थर्मल एनर्जी. टेम्परेचर वाढवून थर्मल एनर्जी वाढवून आपण काय करू शकतो, इलेक्ट्रॉन्सला एक्साइटेड करू शकतो. ॲट दॅट एक लिमिटेशन आहे, आपण पेक्षा जास्त जर थर्मल एनर्जी वाढवली, इजी इज द बँड गॅप एनर्जी, बँड गॅप एनर्जीपेक्षा आपली थर्मल एनर्जी जर जास्त असेल तर तेव्हाच एखादे इलेक्ट्रॉन्स they are reach in the conduction band and they start to taking the part of conductions. This is all about what is exactly happened inside the semiconductor. This is the band theory of semiconductors. Let's draw some band structure here and just distinguish between the metals, band structure of metals, band structures of insulator and band structures of semiconductors. Let's see band structures. Band structures. First, the figure A is for the metal. Then consider this is the valence band of that metals and this is the conduction band. I will be right to use the different color for the drawn of conduction band, that is this is the conduction band. The CB is the conduction band and VB is the valence band. This is the figure A for this is the band for the metals. In the metals or in the good conductors, the valence band and covalent band, the valence band and covalent not a covalent, that is conduction band, the valence band and conduction band are overlapped, for these, due to overlapping, the band gap energy, the gap will not be happen in here, band gap is could not be present here and the band gap energy is very very negligible and the easily excited of the electrons which can be present inside the valence band. जे काही व्हॅलेन्स बँडमध्ये असलेले इलेक्ट्रॉन्स आहेत ते इझिली एक्साइटेड होत असतात आणि कंडक्शन बँडमध्ये जात असतात विदाऊट इन्क्रीजिंग एनी थर्मल एनर्जी. कुठल्याही पद्धतीचा थर्मल एनर्जी अप्लाय न करता आपण काय करू शकतो, दे आर ऑल्सो कॉल्ड ॲज गुड सेमीकंडक्टर. The electrons which can be taking the part of conductions in which they are inside the conduction band also. It must be inside the conduction band. जे इलेक्ट्रॉन्स कंडक्शन बँड मध्ये असतात तेच इलेक्ट्रॉन्स कंडक्शन घडवून आणण्यामध्ये भाग घेऊ शकतात, अदरवाइज नो. देन हे कंडक्शन बँड मध्ये तर ऑलरेडी असतात, त्याचबरोबर इझिली एक्साइटेड होऊ शकतात. त्यामुळे आणि जी बँड गॅप आहे, एनर्जी गॅप आहे इन बिटवीन द कंडक्शन बँड अँड व्हॅलेन्स बँड, इट इज अ व्हेरी निग्लिजिबल असल्यामुळे ओव्हरलॅप झालेला आहे. देन द इलेक्ट्रॉन्स विल इझिली excited and this is why they are called as good conductors. The next one, the figure B for the semiconductor. Figure for the semiconductor. The semiconductor, it is a material, the conductivity of that material is in between the conductivity of the metals or good conductor and conductivity of the insulator. They are bad conductors. Then I will be drawn one of the diagram here. This is the consider, this is a conduction band here and this is one another is a valence band here. This is the conduction band, I will be drawn CB and this is the VB valence band, and this is the some energy gap is present here, that is the Fermi levels, Fermi level gap. This is called as a Fermi level gap, and this Fermi level gap is जर एखादा इलेक्ट्रॉन्स ह्या एनर्जीपेक्षा, दस कन्सिडर दिस इज बँड गॅप एनर्जी इज इझी, देन एखाद्या इलेक्ट्रॉन्सला इतकी थर्मल एनर्जी दिली की ती थर्मल एनर्जी इझीपेक्षा जर जास्त असेल तर व्हॅलेन्स बँडमधून इलेक्ट्रॉन्स एक्साइटेड होऊन कंडक्शन बँडमध्ये जातो अँड देन दे आर स्टार्ट टू taking the part in the conductions. This is all about the band structure of semiconductor. And the last terms, the last band structure is band structures of band structure of insulator. Here that is figure C for insulator. This is the conduction band and this will be valence band, VB valence band, and this is the conduction band. The band gap between the conduction band and in valence band is more, that is a Fermi energy level. Fermi level is more in insulator. त्यामुळे कितीही जरी टेम्परेचर वाढवला तर व्हॅलेन्स बँडमध्ये असलेले जे काही इलेक्ट्रॉन्स आहेत ते इझिली कंडक्शन बँडमध्ये जाऊ शकत नाही, बिकॉज दिस इज अ लार्ज डिस्टन्स बिटवीन द कंडक्शन बँड अँड energy band, the large band gap. Then let's do some fun for the comparison between these three bands. The band gap, first terms is A, that is the band gap. We are studying the band gap. Then band gap is the band gap of the insulator. I will be right here I. The band gap of insulator is more than the band gap of semiconductor, that is S, and more than the band gap of good conductor, that is C. The band gap is which material has a more band gap. Please remember for the MCQ, which energy or which material is a more band gap. This energy, this band gap energy or band gap is called, the answer is insulator. The insulator has a more band gap energy or more band gap. Then this is all about which one material is overlapped, inside that overlap the conduction band and valence band. The material is a metal. All metals or conductions are the valence band and conduction band inside the metal or inside the conductor is overlapped to each others. This is the question number 2. Then in the next lectures we are discuss the types of the semiconductor, that is the intrinsic semiconductor and extrinsic semiconductor. Intrinsic semiconductor and extrinsic semiconductor are classified on the basis of impurity will be adding in that semiconductor, in the germanium and silicon here. Then extrinsic semiconductor are also classified into two types of the semiconductor, then P types of a semiconductor and N type of the semiconductor. We are discuss one by one in the same topic, that is semiconductor.